Excelerate scheme's been around since September 2019 now, so in the scheme of things it's still relatively new. We've obviously had two very, very difficult COVID years where, whether it be us as BDMs or TASMs, we've not really been able to get out and see many of you. But we're getting there, we're back out, we're starting to see people. The good thing about the new scheme, it's very seamless. The journey through the scheme is actually automatic, it's seamless, so the more boilers you do, the further up the loyalty ladder you go, as you can see on screen. Some of the initial benefits have been brought over from the original WAI scheme, but we've also put some new ones in there for you guys to benefit from. Certainly, again, Worcester installers aren't necessarily WAIs, but again, you can get some of the more traditional benefits that were only exclusively open to WAIs. There's some good things on there. For me, training discounts. Now, if you look at our ACS renewals, they're ridiculously cheap. It's brilliant to be able to access some of these benefits. But again, some of the newer things, some of the things like the gift vouchers, dependent upon where you are on the scheme itself, access to the Worcester Bosch MasterCard as well. Again, that's new. For me, the biggest one, which has only ever been available for WAIs, is the potential to unlock, must stay away from those speakers, the potential to unlock the extended guarantee. Now that again is something that we've put in place for Worcester installers prior to getting up to WAI level. When you do get up to the WAI level, again, something that's relatively new for purely Worcester installers is 15 promotion support points per boiler, which you can then use towards either going on to something like the Worcester Bosch MasterCard, or even advertising, marketing, things like branded workwear as well. When you do make it up to the WAI level, which is 21 boilers and above, your promotion support volume does increase up to 20. That goes into effectively a fictitious bank account, and again, it can be used towards building your business, towards advertising, towards marketing, which from our point of view we like to think is quite unique in the industry. On top of that, you've also got things like access to the Find an Installer schemes, where consumers can go on, connect directly with your business, and we can connect you directly with installers. Again, taking it a bit of a step further with something like the fast track scheme as well, where we will literally send one customer to one installer. So again, just trying to help grow your business. One of the big things, which Alex is going to talk about a little bit later on as well, when you get up to the WAI level, is access to the Navuna full finance offering. So for me, not going to steal any of Alex's thunder, as I've already said, which is normally his trick. But again, that's definitely something to look at. The big one is then when you get up to WAI level, access to the free of charge WAI guarantee of up to 12 years for boiler, filter, flue, every single Worcester product on that actual installation itself. Going on to what I personally believe is a very unique, very distinct role within goddamn speakers. Very.
I'll go over there.
Yeah, but then I'm by that one. Oh, louder. Something that is very, very unique to Worcester Bosch, I personally believe, in this industry is access to a team of 7 national business development managers throughout the country. We like to think we're very specialised. We don't talk about boilers, we don't talk about product. We help you grow your business purely through advertising and marketing. We're completely unique in the industry. We're directly employed by Worcester Bosch. Everything we do is genuine, it's honest. We don't charge for it. There's no gimmicks, there's nothing hidden. There's other companies out there who, careful, who will charge a lot of money for some of the lessons that we will give that is absolutely free of charge. You know, some of them will charge over £1,000 a month, which is ridiculous. We're here. We get paid whether you use us or not as WAIs. Make use of us. And there's a lot of different things we can talk about. A few of them up on the screen, but there's so much more. whether it be actual advertising or marketing, even looking through your business's website. For us, it's what we do day in, day out. We're here, ironically, to look after you as installers more so than looking after our own company, because we know if we look after you as installers, your business is going to grow, you're going to install more boilers, which in turn then helps our own business grow. So we're here. Please feel free to reach out to us. Myself, my colleague Terry Morgan, we're here all day. If you're interested, dependent upon where you are, in either sitting down with me, look after the southeast, Terry looks after the naughty elephant squirt water, so Terry looks after the northeast, so I've always got to do that. Come and grab us. If you're not in our respective areas, we can certainly put you in touch with your relevant BDM and we can go from there. I think that's it. Now, move back a little bit from the speakers, because Alex is known for being a little bit loud. But without further ado, I need to hand the mic over, without feedback, to Alex to talk about finance.
Thank you very much. If you just want to take a seat. Firstly, I'd like to point out that none of that was scripted. But thank you, Matt. So yeah, my name's Alex Swan. I'm the Business Finance Manager here at Worcester Bosch, which means I deal with everything to do with consumer and commercial credit for you, our installers. And I'm going to give you a very, very quick rundown of why we are recommending you consider adding a commercial or consumer credit option to your business to help you grow, help you develop. So the first thing for me is about understanding what it brings to your business. Okay, why are we suggesting it? Now, firstly, the ability to increase. I've got to remember to move the mic with my head. I'm not very good at that. The ability to increase order value, the ability for you to enable to increase the volume or the financial value of your works, the ability to attract a larger customer base, and finally for me, the ability to improve cash flow. Considering what's going on right now, especially, I think cash flow is something all of us struggle. Would I be right in assuming currently we're 7 days, 14 days invoicing? Is that generally how we're dealing with our customers? Yeah, which traditionally is what's happened with our industry. Simply by adding a consumer credit option, all of that can change. So to start with, we know for a fact versus our research working with Navuna Personal Finance that consumers who are using a monthly payment option for their boiler installation are likely to spend up to 30% more when paying monthly versus paying up front. Now let me just point out, I'm not suggesting we just charge 30% more for the same level of work. That's not something we'd ever advocate. But the ability to give the customer the job that they actually wanted rather than the job they felt they had to settle for. How often have you done a boiler on a heating system that really the system should have been done at the same time? But most people have got 2.5 for a boiler potentially, but not another 15, 16, 1700 for the system. Well, all of a sudden, depending on your credit option, that's now 16 quid more rather than 1,600 pounds more. So the ability for you to increase the product types, to increase the average cost profit per order is fantastic within consumer credit. Next is about that larger customer base. You are premium installers, we are a premium product. By design, we attract a certain demographic of members of the public. But I'm absolutely convinced that if I was a member of the public and I wanted a boiler, I'd want an accredited installer, somebody working with the leading manufacturer, and I'd want a premium product. Doesn't mean I can have it, says the guy sat here in Primark trousers. You know, we go with what we think we can afford, don't we? Well, all of a sudden with a consumer credit option, that barrier, that price barrier, and that perception of a price barrier disappears. So you're going from perhaps 20 to 30% of the market up to sort of 70, 80% of the market you can now attract without reducing your margins, without having to lower your quality or lower the offering that you're providing out there. And the last one I'm going to bring up today is about cash flow. Right now it's the absolute bane of our industry, keeping you guys going, because of course you're fronting these jobs, aren't you? Big deposits are pretty much a thing of the past now. You guys are having to front this job. Now with our consumer credit options, payment is within 48 working hours. That's cleared funds into your bank account, 48 hours. Now that's quicker than pretty much any other system, unless you're standing there with a card reader in front of that customer's face on the second you finish putting the boiler on the wall. So from that perspective, that's the little quick bits I'm going to give you here today. Personally, I could speak for hours on this. I'm known for you leave a gap, I'll fill it with words. So I'm going to try and bring this down now to my last slide, and that's about what Worcester Bosch can do to work with you as well. Now, as I mentioned earlier on, and Matt mentioned, we work with Navuna Personal Finance, formerly of Hitachi Capital, you probably would have heard them from, one of the leading consumer lenders in the UK. We have schemes for every single type of business and size of business. So right down to you doing your very first Worcester Bosch boiler onwards, we've got a scheme to work with you. Our schemes are designed to grow with your business, so you can't join the wrong scheme. You can join a scheme that suits your business now and develop along with your business all the way through. Remember what the next one is on there. The support, it's in the next two really. I think the bit I'm personally most proud of, and I know Worcester take to heart, is helping you. If you want to come down this road with us and start looking at consumer credit, we're not going to send you an email and say off your pot. You get hands-on direct support from either myself or the wider BDM team, right from the application stage, through your training, through then to trade-in. Our job really is to give you a better return on investment. That's our aim. So we are here to help day in and day out. That is done through training courses, mentor events, marketing, advertising, guides on how to do things, and again, having a permanent point of contact for your business to ring up and say, how do I do this? Is this legal? Should I say that? How should I do that? That's our standard and built in from day one, completely free of charge. Now, I'm not going to pretend to you that adding consumer credit to your business is free. It's not. Everything's got an investment, but you will not pay Worcester Bosch a single penny for offering consumer credit through ourselves. Okay? And anything you do have to pay out, we've worked very hard to negotiate considerable discounts with those partners moving forward. That brings me down to the end, brings me down to the end of my presentation, which is to say thank you very much on behalf of Matt, myself and Worcester Bosch for spending the last 15-20 minutes with us. If you'd like to talk about consumer credit, your business, joining Excelerate or getting more out of Excelerate if you're already on there, myself, Matt and the wider Excelerate team, we're here all day. Feel free to grab a coffee, make sure we've scanned your badge, and thank you very much, and I hope you have a great rest of your day. Thank you.
My name is Ewan, so I'm going to give you a quick sort of overview of the background of net zero, how we're going to achieve it as a heating industry, the different options that we have, and also at the end of it, a little bit on hydrogen. So energy consumption in the UK, so heat represents nearly 50% of all UK energy consumption. And new existing homes equate to sort of about 20% of emissions. So you can see why the government is really actually sort of pushing the heating industry to sort of push for sort of become more sort of carbon neutral. And also in 2019, the UK government mandated that by 2050, the UK will be net zero. Ambitious targets. This is a quick route. So we had the Future Homes consultation in 2019, and recently we've had the update to Part L, where it's talked a little bit about low temperature systems. The fact that all new systems have to be designed to sort of be acceptable for renewable technology. 2025 we've got the Future Home Standards, where in new build you won't be able to install a sort of a fossil fuel appliance, so it'll be predominantly heat pumps in new build. And then as we move forward, you'll see there's a target to half energy usage in new builds by 2030. This is a beamer slide, and on the left-hand side it shows you the actual sort of technology mix. So the blue on your left is predominantly at the moment gas central heating, and there's a bit of electric heating, heat networks, oil, heat pumps. And on the right, where they perceive, or the industry perceives it will be in 2050. So predominantly the grey is heat pumps, hydrogen, and almost 18-20% the government's given a target of actually moving towards heat networks. Very ambitious targets. We've still got a long way to go when you consider that last year in the UK we stored roughly around sort of 50,000, only 50,000 heat pumps compared with 1.5 million boilers. So the government's pushed out a load of policy documents. So this is the 10-point plan that was in the news. And point 2, they've actually put a section on hydrogen. So the government's quite committed to hydrogen in principle, although the industry's got to prove it actually sort of works according to, and it's safe to do so. So they pushed out the hydrogen strategy as well in August 2021. Where they clearly said hydrogen is one of the handful of new and low carbon solutions that would be critical for UK's transmission to net zero. The big thing that actually really indicates the sort of technologies that they're pushing, and it was the actual sort of the heating and building strategy that came out last year as well. And the 4 main points on there really is heat pumps, which we've all heard about in the news. And they've given a target by 2028, 600,000 heat pumps, which is a huge target. It's not our figures, it's the government's aspirations. And also a push. Heat pumps are generally more expensive than a boiler, so there's a big push to actually sort of reduce the cost of a heat pump to make it more affordable to the end user. Hydrogen is a key topic. So they're going to make a strategic decision on hydrogen in 2026. We'll go more into hydrogen a little bit later on about the project. And also potentially up to 48% of current home heating could be on hydrogen by 2050. And then we have heat networks, so where you have one central system as a heat source, and then you have lots of, and it heats lots of apartments, for example, in a block of flats or the estate. And the government's pushed like an 18% target on that. And other technologies such as bioenergy, electrical heating, also will have a part to play. I think the key thing is diversity. It's not. This is another beamer slide, and it just really shows the actual the sort of things going on in the background, which really sort of as a heating company, that this is all going to, in principle, this will all be worked out for you by the time these these come into place. But one of the big things is on here is that the government's talking about what they call a new market-based mechanism, where potentially that manufacturers, especially boiler manufacturers, depending on their market share, will be required to actually sell a certain proportion of heat pumps. Or if they don't, they get financially penalised. That's currently a huge debate going on at the moment, whether it's actually fair in the first place. Currently at the moment we've got the boiler upgrade scheme, so you can get £5,000 to £6,000 for grants to install a heat pump, so that you can see the momentum, the push they're doing. There's probably not enough incentives yet to get the market moving, but it's a start. So this is the map. So on the left-hand side, on this light blue, you can see it's predominantly sort of natural gas, 95% probably of all the domestic installations. And as you move over to the right-hand side, you see how the other technologies start to sort of move. So you've got hydrogen ready, then you've got hydrogen, you've got something called a hybrid, which we'll talk about a little bit later, air-to-water heat pumps, heat networks and ground source heat pumps. So you can see the diversification that the industry believes it needs to get to ensure sort of a net zero. So technologies that we've got open to us. So heat pumps. So that's in most situations of a heat pump, you'll need an indoor unit, an outdoor unit, and also you'll need a cylinder. They're currently more expensive than a gas boiler, so that's a bit of a concern for a consumer. So there's possible sort of incentives to actually increase heat pump sales. So as just mentioned, we talked about the actual subsidies, like the boiler upgrade scheme, where you get £5,000 to £6,000 per installation. But that really just covers the heat pump. It doesn't necessarily cover modifications to the property. We've got the market mechanism, and also potentially to actually move VAT. Currently, I think on a heat pump it's about 5%. And then also looking at potential rebalancing of the electric gas prices, which would be an intervention by the actual government on things like levies and things like that. Hybrids. So hybrid is a system where you have a heat pump operating with a boiler. So I think in the middle of it you have what's called a control unit, which is actually this is one here. So you'll have a heat pump like this here. You have the hybrid box, and then you have a boiler over there, and it will choose which is the most efficient fuel to use based on the actual outside air temperature and the flow temperature inside the property. And it's sort of the heat pump will be the lead, and then the actual boiler will top it out or use it for domestic hot water. And generally at sort of low temperatures, you'll see more of a share taken by the boiler, but as the actual ambient temperature increases, the heat pump would take more of a proportion. We've done some trials in Germany, and they found out that when it's done sized correctly, the heat pump takes about 90% of the load of the actual hybrid system. So it's a good solution, especially with the housing stock we've got in the UK as well, not being as energy efficient. And then we have things like electric. Not a fan of that personally. It's relatively straightforward to install, but then you've got things like sort of you're very, very sort of tied into sort of a utility energy cost, and especially where a lot of these things were installed where it's sort of like sort of blocks of flats. Quite often when people on low incomes, you've got to think about the fuel poverty question. Heat networks, so the government's given a target of 18%. It's a great technology. You have a central source. So in this diagram over here, on the left-hand side, that is the only source of heating, and then it supplies hot water to the actual community, to the businesses, to the apartments, to the flats. And then you've basically got one heat source that you need to really sort of convert or change if you need to. So it can be generated by gas boilers, CHP, and renewables. And the outputs go from a sort of a few hundred kilowatts up to many megawatts. And the advantage is, as you know, from a fluing, basically you only have to take one combustion analysis, or you don't have to go through every single sort of property to actually do sort of a flue gas analysis or safety check. And then we've got the good old condensing boiler. Today, over 23 million homes have gas central heating. So, and 1.5 million sort of homes have oil central heating. So just to change those to heat pumps is almost is an extremely arduous task. So there's got to be other solutions as well. So what we think is diversification. It's having the right technology for the right heating system, the right type of property. So I'm going to talk a little bit about hydrogen now. So this is just almost, if you were going to sort of install a heat pump into your house now, you'd have to take the boiler out, you'd have to put an indoor unit in, and also an outdoor unit like this one over here. You need a hot water cylinder, because if that was a combination boiler, you wouldn't be able to, a heat pump won't be able to give you the sort of the temperatures that a combination boiler can be, so you'll need a cylinder there as well. You may have to change your radiators and your pipework, because predominantly, up until very recently, our systems are designed, for 70 to 80 degree C temperatures on the radiators. Those heat pumps, to get the actual sort of efficiency, you need to operate them around sort of 45, 50 degrees, 55 degrees. And because it's lower temperature, you need more surface area. And also, you may have to change the control system, because heat pumps work better on things like sort of weather compensation, where it actually measures the outside air temperature and the flow temperature inside the actual property, and then determines the sort of amount of energy you need to input into the system. Or you could just change the boiler to a hydrogen boiler. How easy is that? One advantage of carbon, you don't have to worry about carbon, so therefore there's no carbon monoxide, so there's a safety benefit from that point of view. We've all heard about some of those very rare cases where people have had carbon monoxide poisoning. The NOx levels, for the test work they've done in engineering, they've found the NOx levels to be sort of lower than natural gas. So when you talk, when you hear about the sort of, obviously the pollution on the inner cities, that's a big plus. So now I'm just going to show you briefly about some of the trials that are going on. Actually, this isn't really a trial, but just so happens the gas network over the last few years has been gradually changed from sort of the iron pipework to sort of plastics, polyethylene. That is perfect for hydrogen, because with the metal pipework, because the hydrogen eventually seep through, but with it being plastic, it can't get through. And the UK has probably got the biggest gas network in the whole world. So that's a really good resource that we need to use. We've invested an awful lot of money in it due to the sort of our reliance on natural gas. So it'd be a shame for it to just go to waste. Then we've got the different types of hydrogen. There are many different types of hydrogen, but the two main ones that we think will sort of help us achieve the conversion to hydrogen are something called green hydrogen, which is hydrogen that's manufactured through renewables. So it's completely sort of carbon zero. So it's created through a process called electrolysis, and you can get that energy through sort of wind farms, wind, solar, tidal. And then there's something called blue hydrogen, which is actually created through methane. So you heat the methane to very high temperature in a process called steam reformation, and it actually sort of separates the actual sort of carbon from the actual from the hydrogen. The downside is that you need to actually capture that carbon and store it somewhere. But there's a lot of sort of investment that's going on in the industry outside our industry, but just generally, to actually sort of create sort of carbon storage sort of practices. And the beauty of hydrogen, you can store it as well, like you can natural gas. At the moment with electric, you can't really store it. So with hydrogen, You know, in the summer, hopefully if there's a fair bit of wind, you can generate it and you can store it for when it actually gets colder in the winter. So the projects that are going on, and the drivers for these projects are really from the government, so actually sort of through some of the papers I've just shown you. It's something called H21. So it's carrying out work to prove that the gas network can safely transport hydrogen on the H21 project. It's something called High Deploy, which is in the northeast, where they're going to actually sort of run 668 homes on 20% hydrogen. And the beauty about 20% hydrogen, you can just use a natural gas boiler. You don't actually have to have a different appliance. So in principle, we could do that today, technically, but we've got to prove it from a sort of on a large scale point of view. High for heat, and that's where it was looking at general sort of it was sort of lots of testing, but also quite a desktop project where they were looking at the safety case for hydrogen, all the way from production of hydrogen through the network, through your gas meter, into the boiler, and into the property. Not just domestic, but also commercial as well. And then we have something called High Net in the northwest, where it's looking at decarbonisation of the northwest. And it's basically, the ambition is to create a hydrogen grid network. And there's a neighbourhood trial that's actually starting in 2023 up in Fife, where a total of 300 homes will be basically running on hydrogen, with people living in them as well. And not just includes boilers, it also includes cookers, hobs and fires. And so these are new properties where people will be actually moving into them knowing that there'll be hydrogen in there as well. And also, from a skills point of view, there's a sort of how we're going to train people up, how we're going to give people the skills. There's currently a project on to develop the training and the assessment for to enable somebody to become qualified to actually sort of install a hydrogen boiler. And that's been done with an organisation called EU Skills that has been contracted by the government to do that. So in that project, all the hydrogen is going to be produced from a wind farm and then go through the electrolysis process and then actually distributed to the properties. And then next stage is to actually do a village trial. So there's currently a design phase going on, and these are the two projects that are actually sort of competing for that. One in Whitby and one in Redcar in the northeast. But you can see, just looking at all these names, there's awful lot of investment going from all parts of the gas industry to sort of try and achieve a positive outcome for this. So the timeline really is, so we've had the single demonstrations. We've got the neighbourhood trial going in 2023. And also we've got a village design trial happening as well. And then 2025, all being well, 2,000 homes using hydrogen will be actually be running using the conventional grid. And the key date is 2026, when the government would decide whether or not it is feasible for us to actually sort of proceed with hydrogen on a large scale. The government's taken a very sort of like safety sort of step-by-step approach. We've got to prove the safety case for each stage before we move on to the next stage, because we don't. And then by 2030, all being well, we'll have a hydrogen town within hydrogen. So product demonstrations at the moment we've had. I mean, there's quite a few to be fair, but these are the ones that we've been directly involved with. There's one at Spade Adam, up at a Ministry of Defence facility, where the first hydrogen boiler has been installed. Also, you can go over to sort of Gateshead and go to a showroom where you can actually see a hydrogen boiler running, but also the cooker and the hobs as well. And also, there's been other trials, and one of those has been a sort of a hybrid demo down in Milford Haven. So we prove really the technology works. It's how we actually get it on the large scale. You know, all the knowledge is there. It's actually how you actually sort of ramp that up on a sort of national scale. And for that, we need obviously this commitment from the government to actually sort of drive that as well. So the hydrogen boiler, so I suppose the key thing about hydrogen is actually a lighter gas. The flame speed is actually 8 times faster than natural gas. So you've got to redesign the burner, some of the components inside. There's lower ignition energy. You can't rely on sort of the conventional sort of flame ionization because there's no carbon to sense the actual sort of the flame. But the good news is the flame temperature for the gas is the same, which basically means reliability of the product as far as seals and gaskets and the heat exchange are concerned, we're predicting will be the same. Currently there's reliability trials going on at the moment. So some of the elements we've been looking at is like flashback prevention, because the flame's 8 times faster. Potentially that, well, being hydrogen, you don't want it going back. You don't want the flame going back down the pipe, so the burner's being redesigned. Looking at conversion, looking at the general performance. The performance of the boiler doesn't change at all really. Things like the noise levels as well. Also, things like materials, are they compatible? And the good news is generally modern materials inside a gas boiler are perfectly compatible for hydrogen. And things like condensate. You get a lot more condensate coming through a hydrogen boiler, but that's not necessarily a bad thing, because it will help with sort of preventing things like freezing, because you've got more energy going down the pipe. So flame detection. So on the left-hand side is a hydrogen flame, on the right-hand side is a methane flame. So we're going down the route of like an optical sensor to detect the hydrogen, because we haven't got the luxury of a carbon that you need for sort of ionization probe. And also, how are we going to convert all these appliances? Can we just change some components in a natural gas boiler? Unfortunately not. Should we just change all the boilers when you switch from a natural gas grid to a hydrogen grid? Extremely expensive and very labour intensive. So the preferred method, which has been agreed by everybody within the industry, is actually to develop hydrogen-ready boilers, where you design a hydrogen boiler that also can be converted to natural gas. So when they actually go in, you convert a hydrogen boiler, you run on natural gas, and then you can convert it to hydrogen just by changing a few components. So the conversion is likely to be a burner, a gas valve or injector, and a code plug, which really is basically sort of tells the boiler what to do. It's the software that actually sort of configures the software inside the boiler and tells it actually it's not natural gas, it's hydrogen. So that's not too bad really. You look quite young, so probably don't remember the conversion of town gas to sort of natural gas. So it's a similar scenario really. Just changing a few components on the boiler. So industry skills and competence is a key thing for us, because currently there's an awful lot of work going in the industry to actually, we can't just let people work on hydrogen boilers. We've got to give them the skills to do so. So currently in the 5 trial, there's a group that's led by EU Skills to actually develop the actual sort of training and the actual assessment procedure for somebody to actually sort of work on a hydrogen boiler. And it's going to be similar to like potentially when the qualification ultimately would be similar to like an LPG changeover. So you have a natural gas boiler, and then you'll convert it to sort of hydrogen. And as the population increases on hydrogen boilers, then the hydrogen qualification would become the predominant qualification you do initially. The conversion kit is going to be capped to about £100, because we can't make it too expensive for the end user, because that's a bit unfair when they've actually just spent some thousands of pounds on their boiler. and the duration of the actual conversion will need to be less than an hour. So I think the message here to get across is that hydrogen technically is feasible, but also all the pain points will be taken out of the equation before it actually gets to the sort of the general public and you guys when you're actually sort of getting trained and assessed on this. There'll be slight variations maybe on things like testing and purging, and also gas analysis, because obviously there's no carbon in the fuel. But most of the equipment that you use now, you'll be able to use sort of in about sort of 10 or 20 years' time. So the message is really that what we're talking about now from zero carbon is not just about one technology; it's about diversification. It's having the right technology for the right type of property and the right installation. So that is really a whistle-stop tour of net zero carbon heating. Anybody got any questions? Okay, well, thank you very much.
working in the centres and external. And one of my the products that I train on is obviously renewables, heat pumps, solar, and you name it really. I get paid to talk and eat. I'm quite good at doing both of them. So we've got a very short half-an-hour presentation to show you the heat pumps that we have to offer, and that would be the full-on heat pump and also one called a hybrid, something that not everybody is familiar with. It gives you another option. So let's have a look. So the heat pump we have to offer comes in two different versions, which I'll mention a bit more later on. But we have one that has a diffuse on the front, which is that one there, and we have one with no diffuse on the front. And that one, it tends to be the main one to go for, but we have that as an option, which I'll cover shortly. So why do we have these different options? Well, the full-on heat pump, that will be for a property that's well insulated, lower heat losses, modern construction, new build, house built up to modern regulations as much as you can. And this heat pump will do everything. So it will do your heating and it will do your hot water, no boiler required. So a whole house solution. Now in that heat pump we do a 5, a 7, a 9, a 13, which is getting close to what single phase will sort of do, and then we do a 17 in 3 phase. Okay. The smallest gas boiler we make is 12. So you can already see on those outputs the sort of properties these devices are suitable for. New builds, heavily insulated, lower heat losses. What about if you've got a property that isn't a new build, hasn't got low heat losses? You've done the calculations and it needs 25, 30 kilowatts. You can't change the windows, it's listed. You can't change the wall construction, it's solid brick. You can't get rid of the fireplaces. It is what it is. And obviously there's a lot of those in the UK. What can we do about that? They want to lower their fuel bill. So we have another option which is called a hybrid. And a hybrid works with an existing boiler, more about that later on, to work together. Okay, so in certain situations it's a heat pump, certain situations it works together with the existing boiler, and in extreme situations it becomes just a boiler again. Okay, so a hybrid system. Now, the customer will most definitely ask you, well when will it pay for itself? Do boilers pay for themselves? Okay, so, but they will definitely ask you about what grant funding, what help is there available. So there's a new scheme that's just come out called the Buzz scheme, Boiler Upgrade Scheme. It's very easy to actually join that scheme. You go on their website, there's about 3 or 4 pages to fill in with details, you press send, and you're on the Buzz scheme. But they will also ask you for your MCS registration number. Anybody in the group today got their MCS? Micro Generation Certification Scheme? Okay, so this is a quality scheme. It proves that you've sized it correctly, it's going to be commissioned correctly, it's going to run correctly, you've told the customer the estimated running costs and how good it's going to be. You don't missell it. There's a lot of paperwork involved. Let's not beat around the bush. It's a big procedure. So it's a big decision for a company to make that we're going to fit a lot of heat pumps. It's worth the hassle. Let's go for our MCS, and that's great. Now you're going to need the MCS because to prove that heat pump has been installed correctly, sized correctly, and it's going to run correctly, the government won't give you the funding. So you need the MCS in order to offer the customer the grant. Okay. So it's something that you really have to have. So I'm only going to fit 1 or 2 a year. Is it worth the hassle of going through the MCS? Probably not. It's a big thing to do. So what help do we have on hand? Well, we do have some help, and that is that we've teamed up with a company called Auto Energy. They're actually about 2 or 3 stalls that way, and they will help you through every step of the process. So when you've got a customer that says, I would like a heat pump, and you think that heat pump is suitable for that property, you go, not a problem, I will contact this company, they will come out, they will do a site survey, or they will do it off architectural drawings if it's a new build, they'll work out the heat losses, and they'll say what heat pump is best for that property. The customer then says, yes, that's a goer, I'm interested in that, I want to go through with this. You give Auto Energy the green light. They will then design the system, size the radiators, the flow and return pipes, estimate the running costs, everything. They will then say, how much would it be to install this system? Because we're going to subcontract the install back to you. Obviously, it's your customer. So you install it on their behalf. Okay? Once it's installed, you then let them know when it's going to be finished, and they commission the system for you. Big important part of heat pumps is making sure it's commissioned and set up properly. So basically, they do the design work, all of the design work, the specification. They even commission it. And the beauty of that is that you can then use the MCS under their umbrella scheme. So they sign it all off for MCS on your behalf, which means the customer can get access to the grant funding. It also gives you indemnity as well. So obviously, because they've sized it and everything, if anything happens in the future, you just installed it to their drawing, so it's their responsibility. So that's a good thing to have a look at. Obviously, they're only a couple of stands down, so by all means, go and ask them themselves. But we do offer that to try and help people through the MCS scheme by going through the umbrella scheme. Okay, let's look at the heat pump itself. So we have two. We have a 7001 and a 7400. The one in the picture is a 7400, and you'll see what the difference is shortly. Before I go on to the actual heat pump itself, one thing that we try and promote is obviously with Worcester you get a guarantee rather than a warranty. So it's fully covered. If anything happens to the unit, we actually send an engineer out to repair it. You haven't got to go buy the part, try and claim it back, fix it yourself. We just send an engineer who fixes it for you. So it comes with a guarantee rather than a warranty. And the standard out the box guarantee is 3 years. But if you're a Worcester accredited, you'll get 5. If you're Worcester accredited and got your F-gas, you get 7. And another big benefit, again, down the auto route, is because we know it was actually sized right, specified right, commissioned right, we know it's a good install, basically, we will then actually give everybody 7 years. So that's something, again, to look for. Now, if you're new to heat pumps, the main engine of that device is a thing called a compressor. Yeah, and that's the sort of thing that we don't want to be changing too often. So the actual compressor, the main engine of that unit, comes with 10 years as standard. We also have a heat pump ready cylinder available. That comes with 25 years on the actual shell of the cylinder, and then 5 years on the component. So 5 years on the immersion heater and pressure relief valve and all that sort of stuff. Okay, so I mentioned we do two. So you'll notice the one has a diffuser on the front and the other one doesn't. So the one without the diffuser, which is the main one that we go for really, the one that people tend to go for, that comes in 5, 7, 9, 13, and as I mentioned, 17 for 3-phase. But if the customer said to you that I'm willing to pay a little bit more or go for a slightly higher end if I can make it as quiet as possible. So our quietest model, if that's something that's really important for your customer, is the 7400. Okay, so it's about 3 or 4 decibels quieter, and for some people that is a big thing. So we do have a higher end, quieter model, but even the normal one isn't loud. So the benefits to the installer, the unit is fully inverter driven compressor, so it starts not as aggressively on the electrical supply, which is good. Also the unit can actually ramp up and ramp down depending on the demand. Also the fan will change speeds too. The unit is a monoblock. Again, if you're new to heat pumps, what does that mean? Well, monoblock is the fact that the refrigeration circuit is all sealed for life. There's no real reason for you to go in there, but it means you haven't got to have your F-gas qualification to fit one. We're actually going to get the energy from the outdoor unit to the indoor unit via central heating flow and returns with inhibitor in. There's no refrigeration pipes to deal with at all. So it's a monoblock, which is good for us really in the UK because not everybody's got their F-gas. The unit has a built-in drip tray inside, so when you remove energy out of the air, obviously that pulls some moisture out. Some units just drip all over the floor. You've got to put gravel underneath them or build a tray into them. That's actually got the drip tray built into it and a connection on the back, so you can just plumb it straight into a drain. We call it condense because it is condensation, but it's not from a flue gases, so it's not acidic in any way, and it could go just to a soakaway near the device. That's fine. The main heat exchanger on the back, the bit that actually brings all the energy in, is made out of aluminium, and if you put aluminium near sea and you have a lot of salt in the air, it can corrode it quite quickly. Ours actually comes with coastal protection as standard. It's not an optional extra you have to pay for, it just comes on it anyway. So it's got coastal protection built in. The unit itself does have a backup electrical heater, an immersion. Now, some people will then go, I don't want that. I've heard horror stories about immersions. We size the unit to work at 99.6% of the time without ever using the immersion. It's there for that odd, crazy night where it goes absolutely freezing, the unit can't respond fast enough, and it gives it a good kick in the right direction just to help you out. It's designed to be on for such a small amount of time, that extra cost is pounds. You know, it's not a lot at all to do that. Otherwise, we'd be giving you a huge heat pump that could do everything itself, that you're going to use it to like 80% use for 364 days of the year. So that's what we use it for. And it can also be used for pasteurising the cylinder if needs be. The flow and returns from the indoor to the outdoor, we don't ask that there's any glycol in there. Obviously they should be insulated, kept as short as possible for heat losses obviously. But if you add glycol, it does lower the heat transfer of that fluid, so we don't ask for any glycol in our heating system. Now it says service friendly, so when the unit comes, all of the actual outdoor pack, the metal work, comes completely separately, so it doesn't get dented or damaged in transportation. And the whole thing only has 8 screws holding it all together, and it comes apart like Lego. You can actually get to the refrigeration circuit on that from the front, the back, left, right, and from above. So it's very good from a service point of view. And you can see the picture there with the metal casing removed. 2 straps, the insulation comes off, the fan comes off with it, and you're just left with the refrigeration circuit at the bottom. I mentioned about noise. It's obviously something that customers are particularly interested in. The 7001 and the 7400 do come as standard with a thing called sleep mode. So if, again, noise is something that's really important to your customer, they're concerned about their neighbour having the windows open, or they're having their windows open at night time, you can tell the unit between this time and this time, can you please optimise yourself for sound? So you don't have to be as punchy or as powerful as you did in the daytime. Sound is important to me in this time zone, and the unit will sort of back off a little bit to try and make it as quiet as possible in that time zone. The 7400, which is our optimised for sound heat pump, if you put it into sleep mode, as you can see there, it goes down to 34.5 decibels. So a very, very quiet unit. If you were to go for the standard 7001, and at a later date noise is brought up by a customer, or on the time of install they're now concerned with noise, we do a sound reducing hood as an accessory, either on one side or both sides, which will again lower the decibels by 2 or 3 decibels. So it's you know, you can actually upgrade the standard one if noise is important to you. Customer benefits. The standard thing we get nowadays is there an app for that? And yes, there is. There's an app for that. So the unit can be controlled by our app. It's the same app that we use on our air-to-air, our air conditioning systems. So the customer can control their heating system via the app. Something we don't tend to do much in the UK, but you will see certain stands promoting it here, is the fact that heat pumps can run in reverse. So that unit, should you choose to, could actually be used to cool the property as well as heat the property. So it's generally done via underfloor heating, and it's obviously best with tiles or a polished concrete surface. But you can then actually draw the heat out of the property by running the unit in reverse and reject that energy into the garden and actually cool the property via the slab. You are then, yes, so it's lovely for patios and barbecues. So you can cool with this unit, it can run in reverse. We have humidity sensors and other accessories to make that happen, but it isn't that common in the UK, but it can be done. I mentioned about the sleep mode. Obviously it's MCS certified in order to get the funding. We do it a noise reducing hood as an accessory. I've mentioned that. So let's look at the actual heat pump itself. Oh, I beg your pardon, we've done that one. We're now onto the hybrid. So the hybrid. So we've mentioned about the house can't be made heat pump ready. The heat losses are too big. The property's too old. It can't be brought up to that sort of standard. Well, all is not lost. We do an option called a hybrid. So this is where we have the same outdoor unit as the full-on heat pump, but now it works via a mixing unit, which is actually this unit here, with your existing boiler. And it hasn't even got to be a Worcester one either. It can be anything. So It's only controlled by 240 or 0 volts via a relay, and the idea being is that it will switch on that boiler as and when it needs to. So in the warmer weather, where your heat load is less and your flow temperature is less, and also there's loads more energy outside, the unit is a heat pump, excellent. And then as it gets a bit colder, and the heat pump then is starting to struggle to cope, it will then bring the boiler on. That boiler could be LPG, oil, or natural gas. They work together, and then when it gets really, really cold, and the heat pump has lower efficiencies and lower outputs, then it will just bring the boiler on as before. Okay, so the two work together. Okay, so with the hybrid, the boiler that it goes onto needs to be a combi. Okay, so the combi does the hot water itself, high temperatures. The heat pump helps out the heater, and you'll see why in a minute. It does indeed. So I've got a bit of time at the end for questions and stuff. But the question was a good question. So how does it know when to do that? So with the actual control on the front of the indoor unit, you tell it your kilowatts per kilowatt. I'll get it again in a minute. Your price per kilowatt for your fossil fuel, LPG, oil, gas. You tell it your price per kilowatt hour for your electricity, and the unit then will then decide which one to use or both based upon the running cost. So if it feels that the actual temperature is cold, the flow temperature is high, and the heat pump is working, but the actual LPG boiler today would actually be the cheaper alternative, it will go to the boiler. Another question? Yeah. You can then change the conversion factor to go for one more than the other. Yeah, so depending on what conversion factor, there's a number that you give it, it will flick between one and the other. And obviously if you put that more that way, it will go more towards that one. The customer can do it, it's not too difficult to do, but maybe when they come to have the boiler serviced, they might say, oh, the fuel prices have changed a lot since last time, can I have this re-looked at to change the priority of one over the other? Okay, so this is what it actually looks like in real life. So we've got a combi boiler there doing the hot water. As I mentioned, higher temperatures. Hot water obviously is smaller demands than the heating. Heating is generally 80% of your fuel bill, and that's the bit we want to try and help out with the heat pump. So the heat pump has a flow and return into the mixing unit. The combi flow and returns go into the mixing unit, and the control unit controls a blending valve inside, which can go up to 32 kilowatts, so we can take quite a big boiler. Big demand, and that then heats the radiators or underfloor. Okay, so that's what it looks like in real life. Now, the actual hybrid uses the same outdoor unit as the full-on heat pump. So again, it's monoblock. You don't need your F-gas to fit it, and it comes in either a 5, a 7, a 9, and then in the quieter option, the 7400, it comes in either a 5 or a 7. You'll notice there's no 13 or 17 in there that we go to on the full-on heat pump. It's only the smaller outputs, and the reason for that is that with a hybrid, we don't want it to go off. We want it to be on all the time. So we actually want to undersize the hybrid so that we get the full use out of it. So we tend to size a hybrid to work on about 25% of the total load. So if you've got a 20 kilowatt heat loss, we would advise a 5 kilowatt hybrid. And the reason for that is that a 20 kilowatt property, about 80% of the time, is about 5 kilowatts. How often is it minus 10? Yeah, so why if it's a huge hybrid outdoor unit that, yes, could do everything it could do, but you're only ever going to use it once a year, why not have a heat pump that can actually help out all the time, but needs a helping hand instead on the colder days? So we actually undersize, which is why we don't do a 13 and 17, because there'll be no need for one. So 5, 7 or 9 kilowatts, 25% of the total load. We want it to be used as much as possible to make it worth their while. Now obviously, if you don't upsize the radiators and you don't upsize the pipe work, that it will try and do what it can. It will help as much as it can. But if you want to actually get your money's worth out of it, you still want to have a hybrid type heating system. You still want a heat pump system. You still want to have rads that run at lower temperatures. You still want to have bigger flow and returns to make it choose to use the heat pump more than the boiler. So ideally, you'd have a heat pump ready system. Now you might then ask, well, if I've got a heat pump ready system, big rads, big pipe work, why don't I then just go for a full-on heat pump then? Because a full-on heat pump, we need a property with low heat losses. This is basically like a heat pump for houses that have high heat losses. That's the benefit of a hybrid, is it can take on the older housing stock that we have that can't be brought up to spec. Yes, only use on a combi. Now, no, so that means that the heat pump hasn't got to be big, hugely powerful to do hot water. It can be sized just for the heating system, which is what we want. But also the reason for that is that we actually brought a hybrid out 10 years ago that could do cistern boilers and it can do all sorts of things, and it was complicated. And we feel at the moment hybrid, it's early days. We're going to bring out a simple one for the majority of the market. Combis are huge in the UK. Let's see how this one goes, and if the market for hybrid explodes, which we hope it does, then obviously that we'll bring out more when required.
When they fill their radiator and it's not usable, but they're still heat from it.
Well, that is a heat pump issue, but let me also mention that is that, are you all aware about the new Part L regulation that came out about 4 days ago? Yeah? Okay, so any new heating system, whether it be gas, oil, LPG, if you install from scratch, so take out warm air, put central heating in, pull out a microbore system and start from scratch, it must be designed to run no hotter than 55 degrees, even on a boiler. So the idea of having red hot radiators, we need to progress to low temperature heating systems on any heat source. So you're always going to have that problem. So this slide just sort of shows that even a 20 kilowatt property, for the majority of the time, it needs about 5 kilowatts. For those odd times when it needs more than that, that's when the hybrid system would bring the boiler in to help out. Okay, so heat pump considerations. What must we consider when we talk to customers about heat pumps? Quite a standard, lovely village home. Okay, yeah, so already when we look at that, I'm already thinking to myself, what's the heat loss going to be on that property? And these are the people that want heat pumps, because they're going to say my LPG bill is big, or my oil bill is quite big. It needs to be helped out. But when we look at that property, we say it's probably going to be listed. So I can't improve the windows. The walls are solid. The concrete floor is solid. Probably not even got a damp proof course in it. Those are the ones that want the heat pumps, and these are the ones where we're going to be saying, well, maybe not a heat pump, but maybe a hybrid. Also, I'm a big believer in, well, let's stick with the oil boiler, but why not help it out? Why not fit an air-to-air heat pump to take on that big knock-through kitchen, dining room, conservatory area? Why not fit solar thermal to actually help out the big hot water requirement for a larger family? Why don't we help out the heating system we've actually already got, rather than looking for a hole, cut it out and start again? Okay? But that property probably would lend itself more to the hybrid if we were going to go down the heat pump route. So things to consider. It's not every property in the UK is suitable for a heat pump, and that's just the way it is. It might have to have planning permission if it's in a conservation area. Obviously with heat pumps we do use them the most in the worst conditions, so we're making it work the hardest when the air is the coldest. The heat pump is obviously sized on the property, exact. So if you fit a heat pump today and in 3 years time they say I want to have a big extension, the heat pump hasn't got any slack in it. You know, it was sized to the property then, not in the future. So these things need to be considered. Is there going to be any big extensions in the future? Now the outdoor unit, even the normal one, the 7001, if you were to have that running flat out and put an oil boiler flue next to it, you would hear the oil boiler flue over that, absolutely no shadow of a doubt. So when we talk about noise, yes, it's something to consider. It's a big question from customers, but really there's things out there that are a lot noisier than a heat pump. Obviously, we are limited in size because of single phase in the UK, but we have three phase, but three phase isn't that common in domestic. Now, again, if you're new to heat pumps, you might not have heard of this phrase before, and people don't want to talk about it, but let's be honest about this, that the units will have to do a thing called defrost. The unit is removing energy from the air. The outdoor unit will go way below zero in some conditions, so the moisture that gets pulled against that outdoor unit is going to freeze. So the outdoor unit becomes a big block of ice, and you can't pull air through a big block of ice. So the unit has to do something to fix that. So they all do a thing called auto defrost, and this is the heat pump will run in reverse. The heat that it was given to the house, it's now got to give to its heat exchanger outside in order to defrost itself. Where do you think the energy comes from in order for it to actually do a defrost? Anybody got any ideas? It comes from the heating system. So if you were to actually hold on to that radiator, at the same time it chooses to do a defrost, that radiator will go cold, because the heat that it once had is now outside, thawing that block of ice off. So things we need to consider would be, how do you want zones? Do you want TRVs? How free-flowing is this heating system? So if you said, well, I'm going to have underfloor heating, no actuators, maybe one or two, radiators, no TRVs, a fully free-flowing heating system, you might not need a buffer tank. But generally, we tend to recommend that you fit a buffer tank. The idea is that the unit will actually heat the buffer tank, and then the buffer tank heats the heating system. Not only is that good for flexibility and opening zones and TRVs opening and closing, the system hasn't got to respond straight away. Take it from here and I'll recover it shortly. But also, if the unit does freeze itself and it wants to do a defrost, it's got access to energy that it hasn't got to take from the home. It will take from the buffer tank itself. Okay? So the units will do a defrost. When they're working hard in hard conditions, it's quite normal to see a unit defrosting 2 or 3 times an hour. How much energy is that? Well, the energy it's using from the home was put there by itself. So if it's sort of 3-4 to 1 putting it in, it's still better than running on like electric, let's say, to defrost itself. But it is an energy usage, but we actually build that into our design process, and our running costs is based upon defrost as well. So, space. We're going to have an outdoor unit, we're going to have an indoor unit, and that has our controller, wiring center, the immersion heater, expansion vessel, PRV, pressure gauge, is all in the indoor unit. You then may or may not need a buffer vessel, sometimes not. Domestically, generally 50 litres. If we start looking at the bigger units, you might need a 120 litre buffer tank, and then also you're then going to need a cylinder. And the cylinder must be heat pump ready, so a nice large coil inside, or maybe a tank-in-tank cylinder. And a lot of properties in the UK have had all of that taken out, haven't they? Now the combi put in its place. So you are going to have to put this stuff somewhere. So again, it's something to consider. Electrical supply. So we've got 2 electricians in the group today, so they'll know all about this. So obviously these things do run electricity. They're going to need a supply. Will the consumer unit take the extra supply? You are supposed to let the district network operator know when you fit electrical vehicle charging points or heat pumps. So if it's the 5, 7 or 9, you just tell them that you're going to do it. If it's the 13, you tell them you're going to do it, and you have to wait until they say, yes, you can do it, before you proceed. If it's the 17, because it's 3-phase, that's not much of a load for it, so you don't need to wait for their permission on the 17. If you do go down the route of getting the third party in to do the MCS for you, not everybody is happy with somebody else coming into their job and sizing it and commissioning it for you. Not everybody they like to have full control. So that's something again you need to consider if you want the grant funding. I mentioned about the immersion being something that you shouldn't be worried about. If it's sized right, it very rarely uses it. It's just nice to be there in the background. Obviously, if it's not sized right, then it will use it quite a lot, and then we do need to be concerned about it. But that's all down to the design process. But also, what you need to consider with heat pumps is that we the European standard says that you must quote your heat pump efficiencies and outputs at +7 degrees. So when a manufacturer sells a heat pump to you that says it's 5 kilowatts, it's 5 kilowatts at +7, doing underfloor heating at 35. Yeah? Okay? Because we're getting the energy from the air, aren't we? Yeah? And I can't control that. It's not a given energy source. It varies a lot. So if that unit was, let's say, doing radiators at 50 degrees, but today it's -2 degrees, it's not a 5 kilowatt heat pump. You need to be aware of this sort of stuff, yeah? So this is why I always say, please get them designed by a third-party company that does nothing but that, or the manufacturer, because you might think you've got a 5 kilowatt load, you might have a 9 kilowatt load based upon that location, at that flow temperature, and those weather conditions. So it's very important that it's sized correctly. And the output of the heat pump and the efficiency of the heat pump is all over the place, depending on what you're asking it to do in what conditions. Okay, now because we're going to be running at much lower temperatures, that's what heat pumps are all about, lower the better. Ideally underfloor heating is the way to go. Underfloor downstairs, maybe radiators upstairs. But with radiators, we're used to fitting radiators that run at 70, 75, 80 degrees. We sort of get used to what a radiator looks like. But obviously we're not going to run at those sort of temperatures. We're going to run really 50 degrees, if not colder if you can. But let's say 50 degrees. So if we took a radiator that run on a non-condensing boiler, 82, and we go to a condensing boiler, they are meant to be bigger because they're meant to run colder. But if we start going to a heat pump, which is 50 degrees, that number at the bottom is actually correct. The radiator needs to be upsized by a factor of 2.4. Okay, so the radiators need to be a lot bigger than we did with boilers. That being said, if the house is a heat pump ready house with low heat losses, the radiator that you would have put in for a boiler will be one of them postage stamp radiators that you see in new builds. So if you actually put a radiator in that looks traditionally correct, without realising it, it's already 2.5 times bigger. Yeah, so most houses that are heat pump ready houses, the rads don't look huge even though they are 2.5 times bigger than you think they need to be. But it's not just radiators that need to be thought about, it's also pipe work. Because we've had it easy, because we're a condensing boiler, we're looking for a delta tier 20. We actually want to lose the heat between the flow and return. That's what we wanted to do, we wanted to condense. So if you took a 50mm pipe on condensing, 20 degree delta, 11 kilowatts through that. So that means most UK homes don't do this, but you could actually run the whole house in 15mm and it'll pretty much work. You'll get 11 kilowatts out of it, that's a lot. But with a heat pump, we're going to work at a delta tier 7, so that 15mm can now carry 4 kilowatts. Okay, much higher flow rates, much smaller drop across the system. So we're looking at an average property of being 28mm primaries, 22 upstairs, downstairs, and 15mm drops to 1 or 2 radiators. Yeah, no 10mm anymore. Well, depends how big the radiator is. Okay, so bigger pipes. Now, the key to heat pumps, whatever heat pump you go for, is insulation, insulation, and insulation. The lower you can bring your heat losses down, even if you stick to oil, LPG or gas, it's winner-winner. It's all about insulation. And just to sort of prove that point, if we look at these 3 properties, old existing, sort of 20-year-old or less new build, and then a dream Grand Designs type self-build, all modern materials, you can see how much the heat loss is per metre change. And if I said to you those properties are all 200 metres square each, so they're exactly the same size, just built in a different way, that's how much difference it makes to the heat loss. Yeah, so there's 2 properties on there which are heat pump ready. There's one that's going to need a lot of work. But hybrid could do it, because the hybrid can take up to 32 kilowatts on its mixer unit. So we could not fit a heat pump for everything, but we could definitely help it out. So, conclusion. We have a whole house solution, full on heat pump, does everything. But if the house isn't ready, can't be brought up to spec, we do a hybrid that will help it out. We do controls, we do cylinders, we do buffer tanks, we do blending valves that can do multiple zones at different temperatures. We've got loads of different options available for you. Don't forget we also do cooling as well in the full-on heat pump. So if anybody would like to learn more, we do have training academies up and down the country. We have mobile trainers, we do online webinars. The courses are booked on our website, very competitively priced. Get lunch as well, if you come to a centre. So you can book on via the website, in the professional section training, and you can book onto the courses. We do heat pump courses pretty much week in, week out at all the centres. So yes, please, if you're interested, please book yourself onto a course. We do a 1 day, it covers the air to water and the hybrid, because it has the same outdoor units. We put them both together, and you'll physically get to take it apart, commission one, set one up, go through it all day, heat pumps, and we try and give you as much hands-on as we can. Has anybody got any questions?
The servicing aspect. Most people that want you to install these will want you back next year to look at it and service it. What's involved with that?
Okay, so you've got an unvented cylinder sometimes, so you've got your G3 servicing to do. The unit itself might have a strainer on the flow and returns. There's a strainer to clean out. That's it. No, there's no F-gas in these, they're all monoblock. Okay, so monoblock means that all the refrigeration circuit is in there, but it's sealed. There's no need to actually run refrigeration pipe, so you don't need to have your F-gas to physically fit it. It's the same as the fridge freezer in the kitchen. It's got the gas in there from the manufacturer, and there should be no need to ever touch it again unless something needs to be removed and put back in again. It's generally 28 mil. But based on distance it might be 35. There's a chart in the manual that tells you how far you can and can't go.
Question there? I've just come in halfway, so maybe a silly question. Do you have to be more electrically or gas or plumbing qualified to work on heat pumps?
Okay, so I do a bit of both, and I would still say that it's probably a heating engineer's job, and you generally would call an electrician in to help finish it off. But it does open the window, because other than MCS, you don't need to be gas safe registered, Ofsted registered, LPG, so it is going to allow the electricians into our industry. There's one over there, that's why I'm saying that. We've let him on the stand under strict conditions. Electricians. That's right. Yeah, so at the moment we're only doing this with a combi at the moment. We've gone for the main sort of bulk of the installs we feel. We allow the combi to do short hot water, high temperatures, which is what combis are very good at doing, and that is obviously going to be quite undersized because that's what we wanted to do with a hybrid. But there is things like system boiler options coming out later on, but at the moment we're just sticking with the combi option to keep it as simple as possible.
This might be a stupid question from the electrician in the group here. Your combi boilers, are they hydrogen ready, you know, for these blends, the gases and stuff?
Okay, so at Worcester we've been hydrogen blend ready 20% since the Mark 1 Junior, so about 16, 17 years. So blend, not a problem. Full on hydrogen, quite a different appliance. Obviously, once we've got some decisions made from the government, we'll look into that. But we have a hydrogen-ready boiler, completely 100% hydrogen, running all over the country in different field trials, and we hope that will be the answer for the older housing stock. We think heat pumps, new builds, heat pumps for houses that can be brought up to spec, particularly if they haven't got gas. That's, for me, is where that's, you know, they sort of sits. And for the existing housing stock, you know, those 2-bedroom terrace houses, very small gardens, if they've got a garden, that we hope that hydrogen is the future. Okay, so the hybrid system, depending on what size you go for, is about £3,000 to £4,000 on top of a boiler install. Yeah. There's no grant funding available for hybrid. Okay, but the hybrid is, as I mentioned, is for the old houses that can't have a heat pump, really. It's the bigger heat losses. But yes, it's not that sort of price range. I mean, the average sort of air source heat pump install, 9 to 11,000, something like that. But that is a £3,000 to £4,000 add-on to the boiler you've already got. Okay. Right then. Well, thank you very much, and enjoy the rest of your day.